Welcome back, this is part 2 of this lesson. We're going to continue immediately from the end of part 1, so let's get started. The last step to enabling that functionality though is to create an auto-scaling group which allows for the automatic provisioning and termination of the EC2 instances. So to do that, on the EC2 console, scroll down to the bottom under auto-scaling and select auto-scaling groups. Click on create an auto-scaling group. We're going to call the auto-scaling group A4L WordPress ASG. Then for the launch template, click in the drop down and select the WordPress launch template. This is the one that you've been working on throughout this advanced demo series. And then under version, you can either pick an explicit version or set to use the latest. We're going to pick the latest. So select latest, which should be version 4. Scroll down to the bottom, because now the auto-scaling group's been configured with the launch template and version to use. Next, we need to carry on and set other options for this auto-scaling group. So click on Next. For networking, it's here where we provision exactly which subnets are going to be used to provision our instances into. So click on the VPC dropdown and make sure that the A4L VPC is selected. So this is the Animals for Life VPC. And then under subnets, we need to select the 3 public subnets. So SN-pub-A, SN-pub-B, and SN-pub-C. So this allows the auto-scaling group to automatically provision instances into any of these subnets as required. At this point, go ahead and click on Next. Now it's here where we can integrate the auto-scaling group with the load balancer. Load balancers actually work for EC2 with static instance registration. Instances are registered with a target group within a load balancer configuration. What auto-scaling groups do when you integrate them is it links this with a target group. So any instances provisioned by the auto-scaling group are added to the target group, and anything which the auto-scaling group terminates is removed from the target group. So we need to attach to an existing load balancer. Make sure Choose from your load balancer target groups is checked. Click in the drop down and select the A4L WordPress ALB TG target group, which is the one that we just created. Under health checks, we can actually pick to use ELB health checks, which are much more feature-rich than the normal EC2 status checks, so we will be using ELB health checks. Scroll down, check Enable Group Metrics Collection within CloudWatch, and then click on Next. To start with, we're going to select one desired capacity, one minimum capacity, and one maximum capacity. It's the job of an auto-scaling group to keep the number of running instances to be the same as the desired capacity. This is the value that changes up or down, and the minimum and maximum capacity provide limits to this. So for now, we're going to leave desired, minimum, and maximum all at 1, and we're not going to configure any automatic scaling policies. For now, it's going to be a static auto-scaling group. So go ahead and click on Next. We won't be adding any notifications for any scaling events, so click on Next. Now we want to make sure that any instances provisioned by this auto-scaling group are recognizable. So we're going to click on Add Tag. Under Key, we're going to type Name, and then under Value, WordPress-ASG, and make sure this Tag New Instances is selected. And this means that any instances launched by this auto-scaling group will be tagged with this name. Go ahead and click on Next. Scroll down to the bottom and click on Create Auto-Scaling Group to create this auto-scaling group. Now if we just click on Instances, right-click on this existing WordPress-LT instance, and then select Terminate Instance and confirm. Let's just get rid of that old instance that was created directly using the launch template. While that's terminating, scroll down and just open a new tab to the auto-scaling group's console. Click on the auto-scaling group, click on Activity, and then just hit refresh. Now what you should see, because we've created this auto-scaling group with a desired capacity of 1, and because it has 0 running instances, it's going to begin the creation of an instance in order to bring the running number of instances to be equal to the desired number of instances, which is 1. So at this point, it's going to automatically provision an EC2 instance. If we go to the EC2 console and instances and then hit refresh, we should see a new EC2 instance, and it should be called wordpress-ASG, and this is the EC2 instance that's been automatically provisioned by the auto-scaling group. But that's just a simple static auto-scaling group. What we want to do is add some intelligence, so let's do that. So we're going to move to the auto-scaling groups console, and we're going to add some scaling policies. So click on the auto-scaling group, select automatic scaling, click on create dynamic scaling policy, and we want to create two policies. We want to add instances when the average CPU utilization is above 40%, and we want to remove instances when the average CPU utilization is below 40%. So to do that, we need to use simple scaling policies. Remember, target tracking scaling adjusts automatically and aims to try to keep a certain value at a certain level. So for scaling policy name, we're going to call this one high CPU, and we need to define a CloudWatch alarm. So go ahead and click on create CloudWatch alarm, click on select metric, then EC2, and then by auto-scaling group. And if you don't see a list, you might just need to wait a couple more minutes for all of this to be populated.
A few moments later.
Click on select metric, then EC2, and then by auto-scaling group. And if you don't see a list, you might just need to wait a couple more minutes for all of this to be populated. What you need to do is to scroll down, and you're looking for CPU utilization next to A4L WordPress ASG. So select that and then click on select metric. Now we want to create an alarm which goes into an alarm state whenever the average CPU utilization is above 40%. So scroll down, threshold type is going to be static. Whenever CPU utilization should be set to greater, and then the value needs to be 40, so greater than 40%. So go ahead and click on next. If you see anything next to notification, then click on remove because we won't be configuring a notification. Click on next again. And then for the alarm name, we're going to use WordPress high CPU. So enter that and click on next, scroll down and click on create alarm. Then move back to the previous tab where you should still have open the create scaling policy, and just click on the refresh icon and then click in the CloudWatch alarm drop down and select WordPress high CPU. Now for action, whenever the CPU is above 40%, we need to add one capacity unit. So make sure that take the action is set to add, and change this to 1 and make sure it says capacity unit. So add 1 capacity unit. And then go ahead and click on create. Next we're going to create the other side of this. Click on create dynamic scaling policy. It's going to be a simple scaling policy. This time it's going to be called low CPU. We'll need to create another CloudWatch alarm. So click on create CloudWatch alarm, select metric again, EC2 again, by auto-scaling group again, locate CPU utilization and click on select metric. This time though, scroll down, it's going to be static again, but instead of greater, it's going to be lower, and again 40 in this threshold box. Click on next, click on remove, again we don't want a notification, click on next again. For the alarm name, WordPress low CPU, so enter that and click next, scroll down and click on create alarm. Once again, go back to the create scaling policy tab, click on refresh. This time click in the drop down and select WordPress low CPU, only this time the action is going to be to remove one capacity unit. So remove one capacity unit. Then go ahead and click on create. So now we have two scaling policies. When the CPU is above 40%, we add one capacity unit, and when the CPU is below 40%, we remove one capacity unit. Now to make this work, we need to click on the Details tab and adjust the auto-scaling group settings so that the maximum capacity of the auto-scaling group is more than 1, because if it's 1, then the desired capacity can never increase beyond that value. So click on Edit, and change the maximum capacity to equal 3. So it should be desired 1, minimum 1, maximum 3. And then click on Update. Now at this point, that is actually a fully scalable architecture. We can test this by simulating some load. Now to simulate this, move back to the EC2 console and connect using Session Manager to this instance. So WordPress-ASG, right click, go to Connect, Session Manager, and then click on Connect. Once connected, type sudo space bash and press enter. And then we're going to run a command called stress. And the whole function of stress is to stress the CPU of this EC2 instance. So in this case, stress is going to use 2 cores and it's going to run for 3,000 seconds. This command again is within this lesson's instructions, which are attached to this lesson. So go ahead and paste that in and press enter, and that begins stressing out the CPU on this EC2 instance. Now what should happen at this point is the auto scaling group is going to detect the increase in CPU. It's going to trigger the automatic scaling rule, so when CPU is above 40%, it will add 1 capacity unit. This will add 1 to the desired capacity value of the auto scaling group, and because desired capacity will be at 2 and the number of running instances will be at 1, it will provision a new instance. Now this instance will be provisioned using the launch template, it will be added to the target group of the load balancer, and then we can cope with more load in our application. Now this can take up to 20 minutes. So at this point, go ahead and pause the video and keep refreshing this activity history, because at some point you should see 1 additional EC2 instance which begins the provisioning process. So pause the video and resume it once you see an additional line in this activity history.
A few moments later.
After a few minutes, you'll note the auto-scaling groups have detected an increase in CPU utilization. The high CPU alarm was triggered, and this causes an increase of the desired capacity from 1 to 2. Now how this translates if we go to the EC2 console and hit refresh is that an additional EC2 instance is being provisioned in a different availability zone, in this case US East 1B. And this is automatic behavior. You can configure auto-scaling groups to perform these automated scaling actions based on lots of different criteria. Auto-scaling groups also allow us to perform self-healing. So if I right-click on this new EC2 instance that's being provisioned and then terminate and confirm that with yes, terminate, then the auto-scaling group will detect that the number of running instances has decreased by 1, and it will automatically provision a new instance to operate in its place. So this is an example of a self-healing architecture, and the same will be true if any of these instances fail the health checks provided by the load balancer. If they fail the health check, they'll be terminated and re-provisioned automatically by the auto-scaling group.
A few moments later.
And there we go, we can see that we've now got a new instance which is being provisioned as part of that auto-healing process. Now if we move back to the EC2 console, and then we move down to load balancers, click there, select the load balancer, scroll down, copy the DNS name into your clipboard, and then open that in a new tab. You can see that we can now access this WordPress application using the load balancer. And doing it with this method means that any sessions in general won't experience any disruption through these scaling or auto-healing processes. And so this is a way that we've implemented a self-healing, resilient application architecture. Now at this point you've completed everything required for stage 5 of this advanced demo series. You've actually now implemented a fully scalable, elastic, self-healing architecture. You've removed all of the limitations of WordPress. You've split the application and database into separate pieces of compute. You've moved the data into an RDS instance. You've moved the WordPress content onto a shared EFS file system. You've added a load balancer and auto scaling group to allow automatic scaling actions, and the load balancer abstracts the sessions so they no longer connect directly to the EC2 instances. And at this point the architecture can scale in and out based on the CPU load. Now this is a simple example, but it illustrates how you can evolve the architecture of a simple application like WordPress from being a simple single server design to something that's highly scalable and highly resilient, and it just requires knowledge of the nuances of the application as well as knowledge of AWS products and services. Now at this point, that's everything that you need to do in this advanced demo series. The only thing that's left is to clean up the account and return it to the same state as it was at the start of the demo series, and that's what we're going to do in the next and final part. So go ahead and complete this video, and when you're ready, I'll look forward to joining you in the next.